The thing that I want to communicate is a motor, an electric motor. What do? What do you put into the motor? An electric, you put gas in an electric motor? Okay, so you put energy into an electric motor, and what do you get out of it? Yeah, so you put electrical energy in, and well, the same thing is true, like if you take a motor, and then you put in work, guess what you get out? Yeah, electricity. And then that's called a generator. So electric motors become generators. All you have to do is run them in reverse. You turn them. Okay, I'm not going to go into the super heavy details of how this works. Just kind of think of it like when, basically inside an electric motor, there is a magnet, an electromagnet, a coil of wire. When you put a current in, that coil becomes like a magnet. There are also magnets already inside the motor. So when you put the electricity into the coil, and then the motor is set up so that when it turns, the electrical contacts flip, and then it sets the current again. So it tries to turn to get away from the magnets that are in the motor, but then the contacts cause the current to flip, and it makes it go back again. So it keeps like being stuck facing the magnets, and then that makes it rotate. Whatever. The big thing is motors and generators are like the same idea. All right. A motor, you put a current into the wire. A generator, you turn the motor itself. When the coil gets turned through that motor, you get electricity. All right. Good. Transformers. There's two equations that are important. One is this. Oh, actually, it should go. And this is power, right? Like I1 V1 equals I2 V2. And also N1 over N2 equals V1 over V2. A transformer looks like this. It's a square of metal.
What's the N?
I'm about to tell you.
Oh.
And then you have one wire coming in like this. Wire coming out the other side, or going in the other side. Okay, how many coils are in the yellow? See, it's like one. It's kind of like, let's just say n equals 2. I'm just gonna make life easy. N equals 2. How many on the blue? There's like n equals 3. Do you see that? So this is N1, that's N2. Now, if I tell you that this is coming into this at 120 volts, can you tell me how many volts are over here? Right? So this, sorry? Yeah. So you just use this equation to come up with this voltage? Do we do this already in the sprint thing?
No, it's not. The sum. The password.
Oh, nice. Yeah, that's good.
Wait, how's it 120?
Oh, this is given.
Oh, okay.
So like basically they give you the ratio of the, like there's 4 pieces here, right? N1, N2, V1, V2. And they give you like 3 of the 4. And then you have to come up with the 4th one. And then you can take that and come up here and figure out the currents. Yeah. Yeah. And this actually happens at your house. The power lines coming into the back of your house are like, I don't know, whatever, several thousand volts. Right? And then, you know that thing looks like a garbage can up on the pole behind your house? Yeah. And then the wire comes from that garbage can down to your house. What's happening there is go this way, and let's say, for example, it's kind of like this. V1 is something like 50,000 volts. V2 is your house, that's 120 volts. Right? And then so if I told you that this has, I don't know, 100 turns, you could N2. The number of turns necessary in that transformer to give your house this voltage. Do you see it? And then if you say this, an average household has a full current of 100 amps. So then, what is the current in the wire? Do you see how this works? Right? Use the two equations together. First, you find, or use this, find N2, and once you, then you can go ahead and go back and get the current, blah, blah, blah. All right, so that's pretty much the last thing I need to say. If you want more of a better explanation of the motor, think of it like this. If I put current through here, is everybody here? If I put current through here, does everybody see the magnet is like this? The magnetic field's like that. Does that make sense? Okay, so let's say that Sarah's north and Kathleen's south. So like the magnetic field's like this, north to south. Then if I stick this in here, this goes like this, right? So that means north is down here and south is up here, whenever I pump the current in. So what I do is I make sure that the current goes in like this. This north faces north, this south faces south. Does this want to stay that way? No, so it flips, it turns. And then when I turn it, I have the same contact here. So then I pump it in again in the same direction. It makes this north, makes this south, and it turns again. That's how an electric motor works. Bye!
What's my clothes?
Oh, spin the box. Yeah, I come by lunch.